So let us start with the concepts of set theory. So this topic set theory is very important for the subject for the examinations like UGC NET and GATE. In both the examination, this topic is having approximately half of the weightage in mathematics, because a lot of the topics which are related to this topic, for example, we have relations, we have functions which are related to set theory. So I'm going to cover set theory from basics, and I'm going to start from the basic terminologies of set theory. If you already know these terminologies, then you can skip this part, because there's no point of wasting your time. But if you want to go through this, then it is better to go through all these terminologies before we start set theory, right? So we can say the concept of set theory appears in all mathematical disciplines, and we'll start with the basic definition of what is a set. We want to know what is a set. So you can say a set may be viewed as an unordered collection of distinct objects. What I'm saying is a set may be viewed as an unordered collection of distinct objects, right? And the elements are basically called as the members of the set. For example, generally a set is represented by the letters capital A, B, C and so on. That is, the uppercase letters are generally denoting the set, and the lowercase letters, for example, small a, small b, small c and so on, they denote the elements of the set, right? So we can say this small a, small b, small c and so on, they denote the elements of a set. Okay, generally if I write A belongs to A, so this symbol is, we read this symbol as belongs, right? So it means that this A is an element of the set capital A, or we can also say that small a belongs to the set capital A, right? And if we say that, we can also say like this: A does not belongs to capital A, and this symbol here denotes does not belongs. Okay, so generally it is a fact that a set is completely determined when its members are formally specified is called as the principle of extension. What I'm saying is a set is completely specified. A set is completely specified when its members are specified is formally stated as the principle of extension. Right? So if we formally specify the members of the set, then it is called as the principle of extension, and we are completely determining a set. Okay, when a set is completely determined or specified, or you can also use a word determined here. Instead of this, you can also use a word which is a set is completely determined when its members are specified in formally stated as principle of extension, right? And we can say if there are two sets, for example, we have a set A which may be containing some elements 1, 2, 3. We have a set B which may be containing some elements 1, 2 and 3. We can say these two sets are equal if and only if they have the same members, right? So what I'm saying is two sets are equal if they have the same members, if they have the same members. That's a very simple definition. I think it is not difficult to understand. And if we say the two sets are equal, then we generally denote it by A equal to B, right? So it denotes that the set A is equal to B, is equal to the set B. And if we write A, it means is not equal. So if we write it denotes that A is not equal to B, denotes that the set A is not equal to the set B. Okay, now there are different ways of denoting a set. We can say there are essentially two ways of specifying a set. We can say how we specifying sets. We can say there are two ways of specifying a set, right? So first of all, the first way is we actually list down the members in the set. For example, if I say A is equal to A, E, I, O, U, right? So here we are actually writing the members of the set. So here we can say this set is completely specified. In the same way, we can also write A is equal to some set, or you can say use a better let us use some other element name. If you write B is equal to 1, 2, 3 and 4, that means B is also completely specified. Okay, so this is the first way of specifying a set. Okay, where these actually are the elements of the set. Okay, now you can note down here two things. Number one, these elements are separated by commas and they are enclosed in these curly braces. Right? And the second way of specifying a set is by showing the properties of the elements of the set. For example, we can say B is equal to X such that X is an even integer, and X is greater than 0. So this is second way of specifying the set. And the members which this set is going to contain, the elements which this set is going to contain are 2, 4, 6, 8 and so on till infinity. Here you can see I have used this sign. Instead of this, I could have used these two semicolons also. It means I'm writing such that, and this comma is actually denoting and. That means both the conditions should be followed in this case. Okay, so for example, we can also write a set like this. A set A, let us suppose we can say a set A can also be written like this. A is equal to X such that X is a letter in English alphabet. X is a letter in English alphabet. At the same time, X is a vowel. If you see, this set A is actually denoting the same definition which this set A is denoting, right? So we could have listed down all the elements in the set. For example, here we have listed down all the elements in the set, and here we are just denoting the properties of the set, right? We can also give set something like this also. We can say there's a set E which is X such that X square minus 3X plus 2 is equal to 0. Right, here in this case we can say E consists of those numbers which are the solutions of this equation. E consists of those numbers which are the solutions of this equation, and sometimes it is also called as solution set of the given equation. It is also called as solution set of a given equation. Since the solutions of the equations are 1 and 2, therefore this set E is actually going to contain the elements which are 1 and 2. Okay, but sometimes we can generally denote like this. If we say there's a set which is F, and it is denoting the elements 2, 1, right? And there's a set G which is denoting the elements 1, 2, 2, 1, 6 by 3, right? In both these cases, or you can say, if we can have one more notation, we can also say E is equal to X such that X square minus 3X plus 2 is equal to 0. In both these three notations, we can say E is equal to F is equal to G, because we are actually listing out down the same elements. Here you can see, in case of G, I have repeated 2 times, and here this is also denoting 2. This is also denoting 2. Generally, set does not contain duplicate elements. Even if I am listing down these many elements here, number of elements are 1, 2, 3, 4, 5, but actually this set is only going to contain 2 elements, which are 1 and 2. Okay, so we can say the set does not dependent on the way in which the elements are displayed. A set remains the same if the elements are repeated or rearranged, and here you can say G is also called as multiset. Here G is also called as multiset. So even if we repeat the elements, it does not mean that we have these many elements. This set is still containing only 2 elements, which are 1 and 2. Okay,